we will kick off this session. This one I'm super excited about. Obviously, AI, LLMs, all of that is a big, it's hot. It's what's in the news. And so I'm sure, like me, many of you are interested in like, how do I roll these into my products? How do I make my products better? How do I not get caught up in the fad of just slapping AI onto something and pretending that it's amazing, but actually building really great products? To talk about that, we've got two amazing people on stage. We've got Dr. Sherry Marcus, who's the Director of Generative AI Research at AWS. And we've got Sajid Mehmood, who's the VP of Engineering at Datadog, responsible for a lot of our product platform, including Bits AI and other AI-driven things within Datadog. So please welcome them with a warm welcome here.
All right. Hello, everyone. Maybe we can start with like a little bit more of an introduction, a little bit more of a background. Sherry, I'd love to just hear a little bit more about kind of what you do at AWS day to day and kind of what brought you here.
Yeah, so I am a director of Bedrock Science at AWS, and Bedrock is AWS's generative AI platform where customers can choose from one of many models and then create a generative AI application using, tooling such as agents or RAG or guardrails type of application. And so what I do is, I have a team of applied scientists and engineers, and we work on the algorithms and development of these systems for Bedrock. Very happy to be here today. Very, very excited about our partnership with Datadog and all of the great work that we do together. And so I'm just happy to chat here with Sajid on, generative AI.
Cool. Yeah, and I'm happy to give a little bit more context. Like I'm a VP of engineering at Datadog now. I've been at Datadog for about 5 or 6 years. And really have worked on a lot of our sort of AI ML products, including Watchdog, as well as Bits, our new sort of generative AI DevOps Copilot. I'm curious, how many of you all saw the keynote where we talked about sort of the newest things with Bits? All right, it seems like a bunch of you. So I get to work pretty closely with the engineers who actually built that day to day. And so it's been, we've been in this space for a while now, especially with our Watchdog products for many years, of trying to bring AI, ML, data science to your observability data, and then in the last couple of years now, really been diving deep into the generative AI space, and so it's interesting. Like we get to see at Datadog both, similar to I think Sherry's perspective, we have a lot of customers that are like sort of relatively that are getting started in their generative AI journey using our LLM observability products, and then we're also trying to build our own generative AI products to help all of you, and so I think in our experience sort of doing that, we've seen a lot and sort of, I think, had our own lessons, sometimes the hard way, sometimes from talking to other folks about what it takes to actually build a compelling AI product. And so we're excited to talk to all of you about our experiences and some of our customers' experiences with that. And so, Sherry, I'll maybe start by just asking you, like, how have you seen, like, as customers are kind of working through this journey of, like, we hear a lot about how, like, oh, you can do prompt engineering or RAG, like retrieval augmented generation, all the way to more advanced techniques. I'm kind of curious to see, like, how have you seen customers start to use some of these different techniques, and how are they progressing and actually building and deploying AI models into production?
Yeah, so the way customers are, so just taking a step back, model customization is divided into different segments, from easy to harder. The first category is ICL, and so this is intra-context learning, where you are asking, you generate in-shot prompts to teach the LLM to better respond to your questions. And this can be very effective. Generally, I've seen customers be more successful if they use more than 5, but less than 20, end shots, because if you use too many, you tend to overtrain your model. And many times I've also seen just prompting the model what outputs you want seems to be effective as well. The second kind of category of model customization is RAG, retrieval augmented generation. And this is the situation where, as you know, the model isn't necessarily trained on that data. It's an external data knowledge base that is accessed by the model, which in turn generates responses relevant to the user query. And the third is fine-tuning, where you're actually changing the parameters of the model. Now, in my experience with customers, I would say number one and number two, mostly number two, because my experience is really with the larger enterprises, is the most popular. I think three, fine-tuning is very much developing. Customers don't understand enough yet about how to evaluate the fine-tuning results. Often it's easier just to use a smaller model and do option 1 or 2. But I think that as the fine-tuning evaluations and tooling becomes more sophisticated, I think we're going to see more and more fine-tuned models out there being developed by industry.
Yeah, and I'm happy to talk, it's interesting you sort of lay those all out. It seems pretty similar to our journey at Datadog. Like this, for us, when we started last year, really as sort of like generative AI really sort of came onto the scene, we kind of tried to do all three of those things at once, right? Like everybody else, I think we were, you start with prompt engineering, it's the easiest thing. So for example, with Bits, it's easy, you start by telling Bits, like, okay, you're a DevOps assistant trying to be as helpful as possible. You say, here are the 10, 15 different things you can do. You can look at metrics, you can look at logs, you can look at traces. And that actually worked like relatively quickly. Like I think from when we decided to work on Bits, like one of our engineers, sort of like one of the like infamous sort of hackers at Datadog who can build things super quickly, had like a prototype of Bits working in like 2 days, like just using prompt engineering. And that was great. It like got us going, and we had that sort of few shots as you described. But to really make it work, like we had to go to number 2, as you said, like RAG, retrieval augmented generation, where you then have to spend a lot of time getting Bits to interpret the information that we're fetching from Datadog. And so there, like, we actually realized that a lot of developing Bits stands on all of the products we've already built. Like having great search made it easier to build great RAG. So, folks maybe have heard that retrieval augmented generation, historically, and I think traditionally when people talk about that RAG stack, it's with a vector database, and you can totally do that. You can use embedding models that Bedrock has, et cetera, to find out like the similarity of different pieces of text and use that to fetch the information you want. But you can also use any other database or any other search system. And so for Bits, we're using a mixture of these things, right? When we're doing like traditional semantic text searching, we're using traditional vector search RAG. But if we want to give Bits more information about what services or upstream or downstream of the thing we're trying to debug, that's not going to use a vector database. It's just going to use our existing service map. So we use that heavily. And then the last area that you talked about, number 3, fine-tuning. Again, like if you go into any of these like out-of-the-box models that you can get and these different chatbots, and you ask it to like write a Datadog query, you will probably get something out of that, right? There's more than enough Datadog metrics queries, logs queries, et cetera, that are like strewn across the internet and in the training corpus of all these large language models that it will produce something. But it's actually not going to be great. And so to make it better, we actually use a mixture of RAG as well as fine-tuning, right? So it was not that hard. We were able to just, you can come up with like a few hundred examples even, or a few thousand examples of pairs of like a natural language query as well as the like correct Datadog query, and just make a model much better at like understanding the intricacies of the Datadog syntax. The last thing I'll mention is that, like, as you may have seen, we have a few features that are starting to play with SQL that are in beta now. And for there, it was so much more straightforward. Like the we didn't have to do nearly as much fine tuning because there's so much SQL all in the training corpus of these models that the models did a great job generating SQL out of the box. But when we're working with like the Datadog's log query language or the trace query language, or whatever, there's some data in there, but fine tuning really added a ton more. So I think Datadog falls into a similar sort of progression that your customers do.
Yeah. I'm actually curious about if you've seen requirements for short versus long-term memory within multi-turn agentic behaviors.
For sure, yeah. I mean, like incident summarization is a great example of this. Like, I mean, for me, honestly, by far the most useful feature of Bits that I use like literally every day, I used it this morning, is, there's always incidents, Datadog's a large enough company, there's always some incident somewhere. And just like, especially as now like an engineering leader, being able to jump into an incident and immediately get a summary helps a lot. And so this is some place where models have improved enormously over the last year. This like long-term memory, like this is what you're talking a little bit about. This like needle in the haystack type thing. So this is like one challenge. Like originally these context windows for these models were quite small, and so you could have a long incident with like a ton of people talking about it, and it just wouldn't fit into the context window. Basically, what you can prompt an LLM with. And so we had to do all these hacks where we would like take the first chunk, summarize it, then feed that summary into the second chunk, and try these different things. Now these modern models that you can get on Bedrock and many other places have context windows that are like 200,000 tokens long, 1 million tokens long, and so mostly that can now get the whole incident in there. But then the tricky challenge, like the first wave of these large context models, didn't do that great at this needle in the haystack problem, where like sometimes in an incident there'll be like one critical thing that was mentioned in the middle of the context window that really needs to appear in that summary, and sometimes these models would miss it because I think the models, I mean, you probably know much more about this than I do. I'd love to hear from you about why they have struggles with this, but I think even now these large context window models are doing much better at these needle in the haystack problem of being able to summarize or retrieve information from these giant contexts from somewhere in the middle.
So I'd like to just differentiate a few things. So when I think of short-term memory, it is context, right? And so you can have longer context and shorter context. From the model's point of view, it doesn't have memory, right? It's not built in within the model. It only responds to the context using the attention functions that's been designed by the model. And so you should think of context as state, okay? At state X, this is what the model believes, to be true. I have found that longer contexts, is mixed, okay? So if you're doing a RAG application, and let's say, it's an incident request and you have 20 tickets, okay, in context. If you look at those 20 tickets, a human being it doesn't make, you have to actually have the LLM re-summarize it, again, for, and then check it. Because if a human can't make sense of what the output is, then you're not going to see an LLM and an agent make sense of it either. So that's kind of a point I wanted to make. But long-term memory is really the sequence of context windows, right, or states, okay, that can be saved over a long period of time, right? And that's really, the crux of what agentic behavior is about, right? So that if we've had customers like travel, right? So you come back, you had a conversation on Tuesday, you were upset, you got a middle seat, right? You're a good customer. You call back 3 weeks. They ask, they apologize first thing. By having that memory, okay, that the agent can come back to, it makes a whole customer experience much richer and for the customer.
That makes sense. Yeah. I realized I didn't really get to sort of the multi-turn aspect of what you were talking about as well. And To be totally honest, I think we haven't really. There's one place where I don't think we've really like hit the limits of these models, since most sessions with Bits today tend to be relatively shorter. As we get more customers using these the autonomous investigations version of Bits, like I think we will start to run into that, because the initial investigation it produces is very long, and the incident that it runs through, and so as we kind of go deeper into the sort of like AI agents, essentially. I always like hesitate talking about AI agents in a Datadog context, because people always get confused with the Datadog agent. But anyway, I think folks probably have heard enough about AI agents at all these conferences these last few years. But as we get deeper into AI agents, that is definitely going to be a challenge.
Yeah. So I'm curious, what does it take to build a great AI ML product?
So yeah, I mean, that's something that we've been thinking a lot about, right? Certainly there's a lot of challenging questions on sort of the science side and the technical side and the engineering side. But one thing that I've really been kind of really focused on this last year is just the UI and UX part of this. Like I think the way that a lot of us were really introduced to generative AI models, like maybe in the very early days you played with some text completion thing, but really for most of us it was chatbots, right? And I think it turned out to be like a shockingly general interface. Like the models themselves turned out to be shockingly general, and a chat interface was also a very general interface. And so it exposed all of us to the ability of LLMs to write, essays for us, or write, or like reason through problems, or summarize things for us. And I think it's great. But I think there's also a lot of fundamental problems with the chat user interface, right? Like one key thing is that there are no affordances, right? There's nothing that like really tells you what is the space of possible things I can do, right? You're just faced with a blank text box. And look, like a blank text box can be great. Like I think, for example, with like web search, we started like in the early days of web search, we saw, there was like 10 blue, or like there would be like a directory, right? So there was like a ton of, you'd have to click through a directory. Then we realized, oh, one text box actually works really well for that. And I think with generative AI models, I think we're still sort of sorting that out. I think we're still in sort of this like directory phase of user interface. And I think what we'll probably actually see is like a significant splintering, right? Because I think there is, again, a lot of generality to the intelligence of these models and to the utility of these models. And so how we choose to package it up into that interface is going to change. And so I think a lot of what you saw in the keynote today was us talking about the user interface of Bits changing from just being a chat bot into something that's more proactive, that will like keep a notebook for you that you can come and read through asynchronously. And that's still very much an area, I think, of like collective experimentation for the industry. And every day I feel like you see something new on the internet of like some interesting company somewhere trying out a new UX pattern for AI agents or for other sort of generative AI tools. And so I feel like it's a very exciting time to be working in this space.
I agree. So one of the things that I've seen, in the industry, just riffing a little bit off of what you were saying, is really about how customers think about which models they should be using, and how to pick them, and about model choice. So, the most expensive part of building out these applications is not the cost of labor. It's actually the inference costs associated, with actually experimenting and running, these models. And so you always want to be able to find the smallest possible model, right, that can be fine-tuned or continual pre-trained to do the result that you're looking for. So what I'm seeing trending, very much is that desire, to cut costs. 2024 for us has definitely been a year of production. Customers are prioritizing the projects that they want to move generative AI in to production, and as well as the costs associated, with it. And I'm just curious, what have you seen, with respect to adoption?
Yeah, for sure. Like we're also definitely seeing our customers start to move their LLM applications into production. And yeah, cost is definitely a major concern that they have. They wanted to monitor like what their token usage is, et cetera. The other big one that I think we see a lot when you bring things into production is just it's sort of like security and responsible AI dealing with
Yes.
hallucinations. I mean, we talked a little bit about that, how we see that from Datadog side in our keynote, but I'd love to hear from you like how AWS is thinking about helping your customers have safe, responsible AI.
Yes, I spend from ideation to production. We think and I think about responsible AI continually, and so we think about it in a few ways. We offer a service called Guardrails as part of Bedrock, and Guardrails does two things. The first thing it does is it denies topics. So if you are a travel business, right, you only want your customers to ask you about travel. You don't want them to ask them about, politics or history. And so you can deny topics within the guardrails so that the prompt will not be completed. There'll be no inference cost associated with that. The second is in the area of content filtering. So this is a situation where you are potentially, asking questions that are, inappropriate or, unsafe, or you're trying to attack the model in some way. And this is a second method that we use to be able to detect these kinds of malicious or, inappropriate prompts. That said, when we look at models that we bring onto Bedrock, we have a trust and safety, and this is any model. We have a trust and safety evaluation where we're really looking at different factors such as faithfulness. So does the model answer the question based on the context that was available? These are like different kinds of benchmarks. Does it exhibit different kinds of bias, all right, associated with the answer? So I find that customers are very concerned about this as they roll out their LLMs to not only customers, retail customers, but even as they're used within their own enterprises. They want to create safe environments for their bidirectionally.
Yeah, I think when we were getting ready to launch Bits, the one thing that everybody loved to try was see if we could get Bits to talk like a pirate. And actually, it generally worked. And eventually, I think when we finally let it go, it would agree to talk like a pirate, but only about DevOps. And we were like,
Yeah,
that's good enough. That's fine.
Yeah.
The brand folks seemed all right with that.
Yeah.
But beyond some of these other things, I'm curious also, hallucinations is a thing you hear a ton about, right? And
Yes.
so I'm curious how you also think about helping customers through sort of hallucinations and making sure that especially if you're on the hook with a return policy or whatever, how you make sure to help customers keep the AI assistants on topic and sticking to the truth.
Yes, yes. So you should hear news shortly on the work we're doing in hallucination. But hallucination can mean a lot of different things. It can mean that it pretends to give you the right answer, when it isn't the right answer, but it sounds very much like it's the right answer. Or it just gives you some nonsense. So there's a lot of there's a spectrum of what hallucination actually is, and there's different techniques for trying to figure out what's correct or not, what type of it is. But that said, there are a few things, provenance, and making sure that there's the faithfulness of the model goes back to the context. Okay. The second thing that we're seeing that work is retrospection. When the model goes back and restates the question that it thinks it's supposed to answer, then the stakes of hallucination decreases, but that costs you an inference. So what you do in lieu of that is you create a prompt template, right? Or you do metadata filtering where you're, putting the correct metadata so that the prompt is responding appropriately to that. The last thing is, again, running different types of benchmarks against the model to see, how they, in what variations, hallucination exists, and then doing a certain amount of prompt engineering up front, depending on what the use case is. Using these techniques, like our guardrails system, which encapsulates this hallucination, is able to effectively filter 85% of inappropriate content with comparable, with over 90%, 92% accuracy. On generalized queries, but it is a continual challenge.
Yeah, that makes sense. I think, like, I guess for us, again, just thinking about as we develop bits, the I forget the term that you use for it, but we wanted to make sure, like, you're hearing something about your systems from bits. We just prompted bits heavily to make sure that whenever it makes an assertion about what's going on with your systems, it just links to where it got that information from.
Right.
So that the user
Provenance.
can always, provenance, exactly,
Yeah.
yeah. So the user can always know where it came from and sort of independently evaluate, like, okay, did it get this right or not? Because there's sort of two problems that track closely, which is like not having hallucinations, but then the other one is actually earning the user's trust, right? And so they're related. Obviously, if you have fewer hallucinations, it'll be easier to earn the user's trust. But sometimes I think there are ways, and actually I do feel like the current crop of models have gotten a lot better at like expressing uncertainty. Like earlier on, the first models that we were all using it depends how far back you go, but in 2023 or like 2022, when these chatbots really got popular, the chatbots were like, they would always be certain, right? They were like, the joke was like they're like a college sophomore, right? Whatever they knew certainly. Now I feel like you'll sort of hear them talk a little bit more about, okay, I'm not so sure about this or whatever. Is that, do you know, like, have they gotten that better through, is that mostly like human feedback, like RLHF, reinforcement learning? Is that what's made those models better at that?
100%, 100%. RLHF, but good, and we've been learning more and more about how to do that well, right? So when you have human annotators, annotating whether an LLM's response is like better, or worse, than other prompts. If you don't have the same teams, looking at them, there can be inconsistencies across the different results, which can, reduce the accuracy ultimately of the model. And so the testing, for annotation, there's a whole science now, behind how to do efficient annotation, but scientific, consistent validation as well. But yes, that's one of the main reasons, as well as the secret sauce really to training a model is all about the data. And the mixtures of data. And so there's been a lot of new learnings in the industry about that. So for example, if you want to train a model to be bilingual, you don't put in 100% English, test data and then 100% French. You have to like mix it in a certain way. And how that mixture actually, what the right calculus is for doing those mixtures when you're training these large models is definitely more of an art I've seen than like a science, because when speaking to these data alchemists, they say, well, it feels right. I've seen this before. I think I want to do it this way. Like only by running a lot of experiments and then doing the analysis of those experiments do you get results. But even, like more systematic results. But even then, they seem very inconsistent. Like, it's difficult to tell.
Yeah, and actually, I come from an engineering background, more so like some distributed systems, et cetera. And as I've dived more deeply into sort of generative AI, I've really started to understand why folks call it science much more so. I think for me, like, as I've watched like our sort of science and research teams dive deeper into sort of model building, kind of going beyond fine tuning, into sort of deeper retraining, working with many more data, I have like a much greater appreciation for how it really is experimentation. And it's much harder to predict this is a little bit of a side, but like as a manager and leader of teams doing this, like
Yes.
you're used to being able to say to engineering teams, okay, what's the timeline? Okay, it's going to take 6 weeks. We've broken it out. Like, okay, good. Like, is the team going to deliver on time? But talking to a science team, they're like, well, we can run these experiments, but we don't know whether any of them are going to work out or not. So, like, sure, we can get these 2 experiments done in those 6 weeks, but who knows if that means we've got a model that does what we're looking for, and so it's a big shift. So I think we're at about 10 minutes left, which feels like a good time to maybe open it up for questions from the audience. I don't know if Jason, if maybe we can pass around the.
Yeah, so if you've got a question, we've got 2 mics in the aisles here. So just queue up behind there and ask your questions.
All right, it looks like we've got our first.
Hi. So I attended the keynote this morning, and looking at the Bits product, you're in the middle of an incident. I have to be able to trust the accuracy of the bot that is giving me useful information to a certain extent. And you talked about provenance and hallucinations. Those can be complicated topics to explain to an end user and why the impact of it. So from a product perspective, how can you explain to end users how to build trust in the actual output of your AI product?
Yeah, I mean, it's a great question. It's something that we spent a lot of time thinking about. And I think the answer really comes down to that provenance, right? Like if you think about like a portion of the keynote when I was talking about, bits like surfacing a relevant change, right? So, okay, we see there's this database that's having issues. When you sort of use, like, I guess, a combination of RAG, essentially, it's a little bit different than classic RAG. We're really just relying on our change tracking product, right? So the product that you heard just about that before then, like that I think feels really familiar to folks. Like, okay, it's a list of all the changes. Like it's a really like, the SREs that you work with who tend to be really skeptical of any sort of newfangled technology, they're really excited about the change tracking stuff. Like, I don't want any of the fancy AI stuff. Like, just tell me, like, what are all the major things that have changed in my infrastructure? And that's great. And like as Galen showed, like we have a UI for that. But when we were thinking about bringing that into Bits, like a lot of for us is really, in some ways, it's a bit like a ranking problem. Like we're not trying to figure out, Bits is not working to figure out what changed. Like we're not asking an LLM, like we're not feeding an LLM like a bunch of raw data and saying, oh, tell us what changed. So there's no real possibility for it to hallucinate the changes. It's just it's using that change tracking product to sort of say exactly what changed, and it's surfacing what it can. And so it's not to say that nothing can go wrong. Like the biggest problem that we have to worry about is sort of just signal to noise ratio. Like, is the change that we showed you useful? Is it annoying in the middle of an incident? But sort of taking that approach of like, we're just going to use these specific tools, essentially, sort of the term of art in AI agent speak. We're going to use these tools that are using sort of traditional systems that we trust and our users trust is kind of the way we're trying to deal with that.
Great, thank you.
Cool.
All right, I'm going to jump in since I don't see anyone lined up, and I'll let other folks get lined up.
Oh.
But
Okay, go for it.
I had a question for Dr. Marcus, and it's mostly as we're thinking about building products, right? And it seems like starting with an off-the-shelf model is like the first step that companies take, and then they're like, I'm going to do a RAG because I've got my own docs. In your experience and as you've been helping AWS customers, where's the shift? Where should companies start thinking, maybe I should start thinking of building my own models, right? Like, because that seems like a pretty big labor jump. Like RAG versus building your own models is a pretty big.
I would highly strongly not recommend, building your own model unless, there really is a business reason, to do so. And as an example, right, Bloomberg has built their own LLM, and with very good reason, because their data is their business, right? And they wanted to create their own LLM to do so. But other than that, just speaking from experience, the ROI, is not there. Okay, if unless there's a really good business reason to do so. I would recommend going to SageMaker on AWS, exploring all of the smaller models there, fine-tuning it, and then you can, bring your own model to Bedrock, and use that model if that's something you really want to fine-tune, use and create.
All right.
That was the question I had, but a follow-up on that was when you have use cases now dealing with RAG where, for instance, you have your metadata and databases, you have your additional data and storage. Now you want to aggregate this information, you want to aggregate the metadata, you want to aggregate the data and storage like in S3. So that's where I was thinking, at what point do you want to consider moving from like the RAG model? Is that the is that like the limit? Are you now hitting the limit of a RAG model?
So you fine tune a LLM, when you have a specific task you want it to be better at. So if you want it to be better at, answering, summarizing financial news, okay, you would create a few examples of test data, with summarizations and good responses, and maybe summarizations and bad completions, and use that as the basis of fine-tuning your model. So the answer is, if you have a lot of data, let me answer it this way. If your data is changing quite a bit, you have no choice but to use RAG. News, okay, is always fresh, and you're never going to be able to fine-tune your model fast enough to keep up with it, right? However, if you want to be able to, you would do both. You would fine-tune your model to make sure that it's responding appropriately, okay, to the timely news or information that you have, while still using RAG. So it's never an either or, it's like a knobs that you have to figure out based on what your business case is.
Yeah.
Thank you.
And one thing I would add to that is, again, like, we all started with these extremely general models and extremely general user interfaces of a chatbot, but oftentimes in a business application, there's usually a few specific tasks that you want a model or assistant or a product, an actual product, to be able to do, right? Maybe it's to help customers through the return process, et cetera. And so there I find that it can be really helpful to fine tune like on that specific task, right? I think sometimes there's a question of like, oh, I want the LLM to know more things, right? Like, oh, the LLM kind of knows the whole internet is kind of the rough shorthand, but I want them to know more about my business. And there you can look at things like RAG, et cetera. But I think where fine tuning has really at least helped us is when there's like sort of very domain specific tasks. So a really simple example in Bits is, okay, we see this problem, this monitor has fired. Which tool should I use? Should I look at metrics? Should I look at traces? Should I look at logs? Right, very specific to Datadog. Figuring out that tool selection is a place where we're looking closely at fine tuning. But I see we've got another question, so
when it comes to building AI products, and you talk about metrics like faithfulness, like hallucinations, building out UX and UI, giving the end user the best experience possible. How have you navigated frustrations where the model is accurate, but the input is not, and the users are basically not in a position to be educated on how to use the model most effectively?
So, like, I guess my frame is that, like, there's this phrase that the customer is always right. I sort of think that as well, right? Like, if the user is like putting in the wrong prompt, that is like a UX problem. That is like a fault. Like, you're right. Maybe the model is correct, but the product has done something wrong if the user is putting in the wrong prompt. And so, this is, I think, a fundamental challenge with chat interfaces. There's so few affordances, and a lot of folks, and we did this with Bits, and you see it all over the internet as well, where people will give you like 4 or 5 example questions of like what you can ask to guide you. And I do think that that's significant, that helps. But it is part of why with like more of these AI agents, I think prompting is there for when you need to do it, but there's other triggers or there's other ways that you ask a model to start doing work for you that is more clearly defined. Like for example, configuring bits to investigate an alert as soon as it triggers. But at the end of the day, like I think, it's our job as product builders to help users put in the right thing and to express what they want. Like it should be easy to express what you want.
Right, that makes sense. And I have just another quick question. When it comes to language models and teaching language models, has there been any exploration on either of your sides about action models where you track user actions and try to optimize, say like minimizing the amount of clicks to get to a click through, on a website, or you have an end user in an organization doing some kind of workflow, and just having tracking on what they're doing manually in order to just identify what's repeatable, what's redundant, stuff like that.
I have not seen that, for LLM applications personally. I mean, I know it's done, as a supervised fine-tuning, exercise, but I'm not aware.
Okay.
Yeah. You can play, like one thing that's sort of, that reminds me of this a little bit is you sometimes, one of the challenges I think with this, if you've ever seen an LLM play chess, you'll quickly realize that it sort of forgets the rules and it gets a hard sense to, it can be difficult for it to understand the constraints of the action model. So I think that's one of the challenges.
Right. Okay. Thank you.
I think we're right at 0 seconds left.
Yep, we are out of time. I know that many of you probably still have questions or very specific ones. So we're going to end here, but I think both of you all are going to stick around. We can take it out into the hallway and you can keep engaging and you can ask them questions, hopefully. But thanks again for your time and that wonderful insight.
Thank you.
Thank you.
Thank you.